Here we have a solid model from SolidWorks with our coordinate system, our 0 location deep inside of the cavity. So I'm going to move my coordinate system to the center of this part by going to our stock setup, and you can choose from a variety of locations where we will automatically set up the coordinate system. I'm going to choose top middle. Next, I'm going to create our stock. You can type in exact location. I'm going to use a grid. Quickly assist me here. Next, I'm going to produce our machining curves. And the silhouette boundary of the part, I'm going to move that up to the top. Next, we're going to treat this as an open pocket. I will use a 3/4 inch end mill. I will leave a little material for a finish cleanup around the outside perimeter. I'm going to hit advance, and I'm going to go in and tell it we're face milling. Our path is going to be our stock, and then I'm going to tell it to use the curve I moved as the island and verify. Okay, we need to tell it the depth, and it's just over 3.5 inches. Now that stock curve I created, I want to tell our simulation to use that as our stock. So we're just going to go with custom stock. This is our new high-speed machining tool path where it takes an even chip load per pass. I'm going to hide our stock. Next, we'll focus in on this cavity right in through here. So that will also be a pocket. We'll use a 1/2 inch tool. Our curve is at the bottom of the pocket, so I'm going to put in a depth of 0. Pick our path. Now from the top, I want to do a helical pass, a helical ramp to getting to that depth so I can take full depth with our new high-speed machining tool path. See, we're going in helically. We have a spreadsheet which can be printed out, and each operation can be edited here. So like our tool number, I'm going to use tool 2 for that 1/2 inch. I'm going to go back to our 3/4 inch end mill and cut out the next pocket. add our plunge option. Our path is down at the bottom. Take a look at what we have so far. Now we have this open pocket. The squares represent an open edge. We'll use our 1/2 inch cutter. Now I'm going to copy the work step and use this curve over here. So back in the spreadsheet, copy the work step. Change our path. Okay, we're just picking wrong. There we go. The position I had, it just happened to be grabbing the bottom curve by accident. We'll take a finished pass around the perimeter. Left for climb milling. We'll use an automatic lead in and lead out. Our path. For our holes, we'll use hole recognition. Go to advance, and our diameter is 788. Our depth we hit automatic, so it knows the bottom of the model. You can add the drill tip angle, hit auto again, and now the body of the drill is at the bottom of the part instead of our tip. And that's a complete model. If we hit verify all, based on our feeds and speeds, it gives us our time. I didn't adjust the feed and speed. In a conventional sense, you could hit calculate for the active material. But with our new high-speed machining toolpath, that feed rate can be increased.